Hello and welcome back again to the comprehensive slope stability course using PLAXIS 2D. This is tutorial number 36, embankment construction on soft soil layer improved with stone columns using PLAXIS 2D. So we will have the construction for this embankment. We have one dense sand layer which is 10 meter, and above this dense sand layer we have a soft soil layer which is 7 meter, and we intend to construct an embankment above this soft soil. But due to the weak shear strength properties of this soft soil, the factor of safety and settlement or deformation for this embankment constructed on this soft soil, the settlement will be high and also the safety factor will be low. That's why we intend to do a soil modification or a ground improvement for this soft soil layer. And in this example, we will try to use a stone column under this embankment. So we will construct this stone column. After that, we will build this embankment. So we will model both cases. Embankment, construction of embankment on natural soil, and also construction of this embankment on this soft soil reinforced with this stone column. So what is a stone column? Stone columns are one of the soil modification or ground improvement method, and they are widely used to improve the bearing capacity and stability of a soft soil or compressible soil such as a soft clay soil. They are formed by installing vertical columns. So these vertical columns can be a gravel or a crushed stone into a weak ground, and these vertical column act as a reinforcement and improve the shear strength properties of the soil. Also improves, also act as a drainage path, path for dissipation of pore water. So to construct these stone columns, first of all, the hole is created using a vibro float or auger. These are the two machines and used for constructing of these stone columns. And after creating a hole, these gravel material or crushed stones are poured into this hole and compacted using this vibro float. So the depth and the diameter of these stone columns depends on the design of a specific project. So we can see after construction of a stone column or reinforcing the soft clay layer with a stone column, the safety factor for the embankment increased from 1.1 to 1.925. So this shows us the importance of modification or improvement of a soft clay layer under the embankment. Also, we can check the failure surface for each cases. We click on safety factor for unreinforced soil. We can see this is a deformed shape, and if I click on deformation total, we can see this is a critical failure surface of the embankment before construction of a stone column, and after construction of column we can see this is a critical failure surface for a stone column. Also, we can check the displacement or deformation before construction of stone column. We can see the maximum displacement is 15 centimeter, and happened at middle of this embankment. And after construction of after reinforcing the soil, the clay layer soil with a stone column, we can see the maximum displacement is about 7.8 centimeter. So we can see how settlement or displacement is also improved after installing the stone column below the embankment. So this was for this lecture. I hope it was clear and useful. Thank you for watching. See you in the next tutorial.